Welcome to Izzo Math. Again, we are still talking about vectors. So in this video, we're going to have these two vectors here, and we're going to talk about how to find the angle between the two vectors. So we want to find theta. Find theta. Okay? So we know that, so this vector v. We know that u dot v equals 5 times 2 is 10 plus 5 times 3 is 15, so equals 25. That's our algebraic definition, where we just multiply the 2 times the 5 and then add the 5 times the 3. But we also know that u times v equals the magnitude of u times the magnitude of v. Did I say time? I should have said u dot v there. I think I said times. So we're dotting those vectors. Times the cosine of the angle between them. We derived that in the last video. So what we need to do now then is find the magnitude of u and the magnitude of v. Well, the magnitude of u is going to equal square root of 4 plus 25, which equals square root of 29, and the magnitude of v equals the square root of 25 plus 9, so that equals the square root of, what's that going to be, 34? So that is going to let me go back and say this dot product u dot v equals the square root of 29 times the square root of 34 times cosine theta. But I know that the dot product for my algebraic definition is 25. So we know that 25 equals the square root of 29 times the square root of 34 times cosine theta. Get my calculator going here because I know I'm going to need it in just a minute. Because I'm going to have to use the inverse cosine to solve the theta. Okay, so we get that cosine theta equals 25 over the square root of 29 times the square root of 34. And let me remind myself, a b squared equals a squared b squared. Yes. So I can rewrite that cosine of theta equals 25 over the square root of 29 times 34. What is 29 times 34? $986. So we're going to get that theta is going to equal the inverse cosine of 25 over the square root of 986. Let's get an approximation for that. So inverse, let me make sure I'm in what mode I'm in. Go on the radians. So inverse cosine of 25 divided by, well, I don't need that since I'm doing the 25 divided by the square root of 986. about 6.64987. 64987. 64987, and that's in radians. Okay, so how am I looking on time? We are looking fine. So we have that theta equals 0.64987 radians, and we know, just to get a little confidence here, we know that the dot product should turn out to be 25. So let's use our geometric definition to get it as well, to make sure that we get 25. And since this was an approximation, it's going to give us probably a little less than 25, but let's do it. So let's do u dot v equals the magnitude of u times the magnitude of v times the cosine of theta. And over here we saw we got the magnitude of u is root 29, then v is root 34. Root 29, root 34 times the cosine of 0.64987. 0.64987. Okay? Plug all that in our calculator, and we better get, it's better be about 25. Okay? But again, this was an estimation. We rounded there, so it's probably going to be a little less than 25. So we got the square root, what was it? Square root of 29, square root of 34. Second square root of 29 times 34 times the cosine of 0.64987, and that's where we stopped. It'll be about 20, yeah, so 25.000000854. So this is about 25, but we know it's actually exactly equal to 25 when we had that little rounding error there. So I hope this helps you out. I hope these videos have helped you out, introducing you to vectors. It's a different train of thought. One of the main things that you have to remember about vectors, that this vector here let's go this way. That vector there is the same as that vector there. Vectors have no position if I made those the same length. So they have no position. They're just measured in their magnitude and their direction. That is, those two vectors are the same as that vector, which is the same as that vector, which is because they all have the same direction and they have the same magnitude. So it's the same as that vector. So a vector has no position. We can assign it a position, and sometimes it's nice to assume that we just go ahead and assign them all the position of that they start at the origin, but they actually have no position. They're only measured in their magnitude and their direction. Okay? See you in the next video.